finding a polynomial of a given degree with given, I think it's complex roots, okay? So there's a theorem that we have that basically says if you're trying to construct a polynomial with real coefficients, if you have a complex 0, like -2 plus I is complex because it has an imaginary number, then for there to be real coefficients, the conjugate also has to be a 0. So it's like we've got a hidden 0 here. They told us -4 is a 0. They said -2 plus I is a 0. Well, then -2 minus I also has to be a 0. So here's how I'm going to write that. I'm going to write x plus 4. That's because if you plug in -4 into this expression, it makes 0. Right? And they said that there's zeros. So -4 plus 4 should make 0. And now I'm going to write x minus a parentheses -2 plus I, because I'd have to distribute that minus sign. And the way this works is that if you plug in -2 plus I in for x, then -2 minus a -2 makes 0, and an I minus that I makes 0. So that's a 0. And then because of that, I forgot the name of the theorem. I don't even know if it has a name, but the theorem that says for real coefficients, you have to have the conjugate, meaning the one with a different sign on the imaginary number. I also have to have this as a 0. -2 minus I. There we go. Let's see if Alex accepts the unsimplified answer. We can simplify it. We have to. I'm not getting my parentheses. Oh, it wants us to expand it. Oh, okay, that's kind of brutal. So they don't want parentheses. They want us to expand it. Okay, so let's simplify a little bit. I'm going to distribute this minus sign. And then I got x plus 2 plus I. Okay, so to write the polynomial in standard form, we have to multiply these two things. Okay? So in order to do that, I use a box to help me keep track of everything. Okay, I'm going to put this on one side of the box, and then I'm going to put this on the other part of the box. One going down, one going across. And then if we draw lines, we can make sure that each term gets multiplied to the other term. Okay, so all you have to do once you've drawn this box is x times x makes x squared, and then get 2 times x makes 2x, and then -I times x makes -ix, and then you get x times 2 makes 2x, 2 times 2 makes 4, 2 times -I makes -2i, x times I makes ix, 2 times I makes 2i, and then -I times I. Now be careful with this. That makes -I squared, which is equal to 1, because I squared is a -1. That's a definition that we have of an imaginary number. I squared is -1, so -1 makes a +1. So if I add all those together, here I'm going with that polynomial, got x plus 4. So we got x squared, and we got 2x plus 2x makes 4x. And then look, you got -ix plus ix, that makes nothing. Those cancel each other out. And -2i plus 2i, those cancel each other out, just like they're supposed to. But you got 4 plus 1 makes 5. Okay, so that's how you would multiply those two things. And so the final part, x times x squared makes x to the third. X times 4x makes 4x squared. And then x times 5 makes 5x. Oh, I want that still. And then you got 4 times x squared. That's going to make 4x squared. And then you got 4 times 4x makes 16x. And you got 4 times 5 makes 20. And so just combine like terms to simplify there. X to the third plus 8x squared plus 21x plus 20 when you simplify. I hope I didn't go too fast. Phew. Okay.